Uh, Hello everyone, good evening. So here we shall explain the rules of congruency of triangles. So as we know, there are five rules of congruency of triangles. One of them is SSS. The full form of SSS is side, 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 side. And there is SAS, which means the side angle side, side angle side. And there is ASA, ASA, which uh, which means which stands for angle side angle, angle side angle, and AAS is also there. AAS means angle angle side, angle angle side, and we have RHS. RHS stands for right angle hypotenuse side, right angle hypotenuse side. So all these five rules can be used to prove that any two triangles are congruent. So now congruent, the word congruent means what? Congruent means that whenever any two shapes can exactly overlap on each other, can exactly overlap on each other. Suppose if I take two triangles, if they are having the same shape and the same size. So congruent figures, it means if two figures have the same shape also and the same size also, same shape and same size. So suppose if we take a triangle ABE and the triangle is ABC and DEF, then if their shapes are same and the size is also same, shape, how to know that their shape is same? So if all their corresponding angles are same, it means suppose angle A and angle D is same, and angle B is also same as angle E, angle C is also same as angle F, and all their sides are equal, means all their corresponding sides are equal. It means AB is equal to DE, and suppose we can show that BC is also equal to EF and AC is also equal to DF. Then it means I will say that triangle ABC will be congruent to triangle DEF. Now this symbol is used to represent it. It represents uh, it represents the statement congruent to, congruent to. So it means that if I say triangle ABC, then I write this symbol and then I write triangle DEF. So it means that I'm saying that triangle ABC is congruent to triangle DEF. And whenever I can prove that triangle ABC is congruent to triangle DEF, then all their corresponding sides and their corresponding angles will be equal. Which means I can say that angle A will be equal to angle D and angle B will be equal to angle E. Angle C will be equal to angle F. And also we can say that the side AB will be equal to side DE, side BC will be equal to side EF, and side AC will be equal to side DF. So I can say that when I say that triangle ABC is congruent to triangle DEF, we should also uh, take care of the correspondence. We should also take care of the correspondence. Correspondence means the corresponding vertex names should be in the same order. The names of the corresponding vertices should be written in the same order. So here, suppose I am saying that angle A is equal to angle D. It means the vertex A in triangle ABC, that corresponds to the vertex D in triangle DF. Similarly, the vertex B corresponds to the vertex E in triangle DF. Then the vertex C in triangle ABC will correspond to the vertex F in triangle DEF. So it means that when I say triangle ABC is congruent to triangle DEF, it means that we are saying that A corresponds to D, B corresponds to E, and C corresponds to F. So it means that here, if I write triangle ABC is congruent to triangle EFD, then it will be wrong. Since why we should take care of the correspondence also. So if I say that triangle ABC is congruent to triangle EFD, then it means that we are saying that A corresponds to E, B corresponds to F, and C corresponds to D. If that happens, then only we can say that triangle ABC will correspond to triangle EFD. Or else, if I see that A corresponds to D and B corresponds to E and C corresponds to F, then we should say triangle ABC is congruent to triangle DF. So now we will explain all the 5 rules of congruencies. So now the first is the side rule or the SSS rule, or you can say the side rule of congruency of triangles. So here the rule states that if the three sides of one triangle, the three sides of one triangle are equal to it means they are equal in length. If three sides of one triangle are equal to the three corresponding sides, of another triangle, then the triangles are congruent. Congruent, as I have told, congruent triangles means that they should have the same shape and the same size. Same shape, it means all their corresponding angles should be same, and same size, it means all their corresponding side lengths also should be equal. All their corresponding sides should be equal and their corresponding angles should be equal. Then only I can say the two triangles will have same shape and same size. So here we can understand this by, okay, so we can understand this by using one application. Suppose it is given that in quadrilateral ABCD, if the side AB equals to CD and the side AD equal to BC, then show that triangle ABC is congruent to triangle CDA. Suppose we are being asked to prove this. So we can prove this by using this SSS rule or the side rule of congruency. How? Let us see that. So now we take one quadrilateral ABCD. Suppose this is a quadrilateral ABCD. Now it is told that AB equal to CD. Okay, so we have to draw it in such a way. Okay, suppose the quadrilateral is somewhat like this, which is ABCD. So here it is given that AB equal to CD and AD is equal to BC. So then we have to show that triangle ABC is congruent to triangle CDA. So now we can draw the diagonal AC. We have to draw the diagonal AC. So here first we have to write given. So how to write the proofs for any for writing any geometrical proofs? First we have to write what is being given. So I will say that in quadrilateral. So except the show that part, whatever is written in the question, we can just copy that in the given part. So we will write that in quadrilateral ABCD. It is given that AB equal to CD and AD equal to BC. So now, and it has been told to prove that triangle ABC is congruent to triangle CDE. And then we will write the proof. In the proof, we will say that, as you can see, in triangle ABC and triangle CDA, side AC is equal to AC, I will write. AC equal to AC, since, or simply we can say AC is the common side. AC is the common side, so it will be equal only in both the triangles. So AC is the common side. So AC is the common side and AB equal to CD, which has been given, and AD equal to BC, which is also given. So here, as we can see that the point B actually it corresponds to D. B corresponds to D and A corresponds to C. A corresponds to C. And obviously, so C corresponds to A. Since when we say A uh, ABC, so we are going along this longer side. So ABC, so I will say CDA. So C corresponds to A. So it means that ABC, when I say, we should write it in the same order only. So triangle ABC, that will correspond to, since we are saying in second, first, and third, so ABC, that will correspond to here also second, first, and third, which is CDA. Okay, so it is triangle CDA. So I should not say ABC is congruent to ACD or DCA, then it will be wrong. But here, when I put them in the same order of their correspondence, so we have to take the same order. Um, we have to take in the same order, then only it will be correct. So therefore, here I will say triangle ABC is congruent to triangle CDA. How? By SSS rule of congruency. SSS rule of congruency. Now here, if it was being also told to show that, suppose it was being told to show that first part is triangle ABC is congruent to triangle CDA, and second part it was told to prove that angle B or angle ABC is equal to angle CDA, then that also we can show. So this is, then we would have written in the two proof. First part is triangle ABC is congruent to triangle CDA, and second part we would write angle ABC will be equal to angle CDA. So then, since as I told, when we can show that any two triangles are congruent, then we can say that all the corresponding sides will be equal and all their corresponding angles also will be equal. And the reason for all of them, we will write as CPCT. The reason is CPCT. The full form of CPCT, it means CPCT means corresponding parts of congruent triangles. Corresponding parts of congruent triangles. So when two triangles are congruent, then their corresponding parts are also equal. So hence we will say that CPCT. So by CPCT only we can say that they are in the two triangles, the corresponding sides will be also equal and the corresponding angles will be also equal. So, here we will say that angle B will be equal to angle D, or simply we can say angle ABC that will be equal to angle CDA. Since why? They are the corresponding parts of the congruent triangle. So the reason also I will write CPCT. And when we prove the first part, then we will write here proved part 1, proved part 1. And here also, since we have proved the second part, so we will write proof part 2. So in this way, we have to write any geometrical proofs. And this part we don't have to write, which I told. This part no need to write, but simply I told for the explanation that we have to write the names of the vertices in the same order of their correspondence. Then the second rule is the second rule is the side angle side congruency. Side angle side, or I can say the SAS rule of congruency. Side angle side rule of congruency. So the SAS rule states that if the two sides, and the included angle, so it means that the two sides which we take in one triangle, let's say PQR, then we have to take the angle P only. It means that if we take PQ and PR, then we should take angle P or QPR, since we have to take the angle which is included in between those two sides which we take. So we have to take the included angle. Okay. So if two sides and the included angle of one triangle, this included angle point is very important. So if two sides and the included angle of one triangle are equal to the corresponding two sides, equal to the corresponding two sides and the included angle of another triangle then the two triangles are congruent. then the two triangles are congruent. So simply it is saying that if I have one triangle, suppose ABC, and one triangle, suppose DEF, then if we can prove that suppose AB equals to DE and BC equals to EF, and their included angle, which is angle B, that is equal to angle E, then only we can say that triangle ABC will be congruent to triangle DEF. Okay. And how? By SAS rule of congruency. And then once we can show that, then we can say that any other corresponding side will be equal and all the other angles will be equal also. How? By CPCT. Simply, once we have shown that triangle ABC is congruent to triangle DEF, then we can say that therefore angle A also will be equal to angle D, then angle C also will be equal to angle F, and AC, the side AC also will be equal to DF. How? Simply the reason is CPCT. The full form is corresponding parts of congruent triangles. So now we can understand this SAS rule more by using one application. So one application is suppose it is told in triangle ABC, and triangle DEF, the side AB equal to DE, it has been told, and angle B equals to, it is told, angle E, and BC equals to EF. Then prove that angle C equal to angle F. So how to prove this? The same way, we take triangles ABC and triangle DEF. So here, then first we will write what is given. So given I will write in triangle ABC and triangle DEF, AB equals to DE and angle B equals to angle E and BC equals to EF. BC equals to EF. So then it is asked to prove that angle C equal to angle F. So angle C, I can also say it is angle ACB, and that is equal to angle F. It means we can also say angle DFB. So then we will write the proof. So the proof, how to write it? I will say that in triangle ABC and triangle DEF AB equal to DE is given. AB equal to DE, which is given, and angle B equals to angle E, which has been told also, which has been given. Or in place of B and E, we can also say angle ABC equals to angle DEF, which has been given, or we can say angle B equal to angle E. And it also has been given that BC equal to EF. And BC, the side BC equals to EF, which is also given. So therefore, we will say triangle ABC, that is congruent to triangle DEF. How? by the SAS rule. So here, as you can see, that angle B is the angle which is included in between the two sides which we have considered. We have considered the sides AB and BC. So angle B only is the angle which is included in between the two sides which we have considered. So hence angle B only we have to take. We have to in SAS rule we should consider only the included angle, not any other angle. So here also, as you can see, DE and EF we have considered. So angle E is the included angle. So the included angle only we have to consider here. So triangle ABC is congruent to triangle DF by SAS rule of congruency. SAS rule of congruency. So I can say, so the side AC also will be equal to DF since why? CP 6 CT. So AC will be equal to DF by CP CT since corresponding parts of congruent triangles are also equal. And then we will write root, or we can write hence root also. Then the next thing is, the next rule is the ASA rule. ASA rule of congruency, or the full name is angle side angle. So here also we have to take the included side. ASA rule of congruency. So the rule states that if two angles and the included side, so the included side, it means that suppose we take two angles, this one and this one, let's say I take it as PQR. So if we take the angles angle Q and angle R, then the included side is QR only. So we have to consider the side QR. Since this side is included with the angles angle Q and angle R. Suppose we take angle P and angle Q, then we have to take the side PQ. Since why? EQ is included with angles P and angle Q. So here it is told if two angles and the included side, of one triangle are equal to two angles and the included side of one triangle are equal to the corresponding two angles and the included side of another triangle, the included side of another triangle, then the two triangles are congruent. Then the two triangles are congruent. So here simply we can understand this by using one application. So simply here it means suppose we take one triangle PQR and suppose if we take one triangle, let's suppose LMN. So then if I can show that angle P equal to angle L and angle R equal to angle N, and we can also show that the side PR is equal to side LN, then we can say that triangle PQR is congruent to triangle LMN. How? By ASA rule of congruency. And then we can say that angle Q also will be equal to angle M by CPCT, and QR also will be equal to MN by CPCT, and PQ also will be equal to LM CPCT. So we can understand this rule by using one application. It is suppose it is told that in triangle PQR, and triangle MNO, angle P equal to angle M. Is told angle P equal to angle M and angle Q equal to angle M. no, sorry, angle N, angle Q equal to angle N, and PQ equals to MN. PQ equals to MN. Then show that triangle PQR is congruent to triangle MNO. That we have to prove. So here you can take two triangles. One is PQR and one is LMN. No, it is MNO. MNO. So here it is given that angle P equals to angle M and angle Q that is equal to angle N, and it is told PQ equals to MN. This is given. Then we have to show that triangle PQR is congruent to triangle MNO. So here also we can see that the vertex P corresponds to vertex M in triangle MNO, and the vertex Q in triangle PQR corresponds to the vertex N in triangle MNO, and also the vertex R corresponds to the vertex R in triangle PQR corresponds to the vertex O in triangle MNO. So when we write triangle PQR, then we should say it is congruent to triangle MNO. Suppose we say triangle QRP. Suppose we say that triangle QRP, then we should write the other triangle also in the same order of correspondence, which means we will say that triangle QRP that will be congruent to triangle NOM. Since why we say that Q corresponds to N here, Q corresponds to N, and R corresponds to O, and P corresponds to M. R corresponds to O and P corresponds to M. So when we write this congruency that it is congruent to, then on the left hand side, the order of the vertex names should exactly match the order of corresponding vertices of the other triangle also, which is kept on the right hand side. So on the left hand side and on the right hand side of this symbol, we should keep the same order of correspondence. So here first we will write given. Given is simply we will write till here, just before show that or prove that whatever is written in the question we will write that in the given part. So here we will say in triangle PQR and triangle MNO, angle P equals to angle M and angle Q equals to angle N and PQ equals to MN. Then then we have to prove that triangle PQR corresponds to triangle MNO. So hence, then we will write the proof. The proof is that I'll write that in triangle PQR and triangle MNO we have been told that angle P equal to angle M, which is given, and angle Q is equal to angle N, which is also given, and PQ. So here you see that PQ is the included side. PQ is the side which is included with the two angles which we have considered. So the two angles which we have considered, the side should be the included among those two angles. Then only we can say it is AAS. Then only we can say it is ASA rule. Or else if we take any other side which is not included with these two angles, then it will be AAS, not ASA. So if we say that it is the ASA rule, then the side should be included with those two angles which we have considered. And if we take any other side which is not included with those two angles which we have considered, then that we will say it is AS. AS means angle side, which is not angle side angle. So if it is angle side angle, the side should be included with the two angles which we have considered, and it is AS or angle side. If we consider any other side which is not included in the with the two angles. So here PQ will be PQ is equal to MN, which is given also, and angle P is shown that it is equal to angle M, and angle Q is shown that it is given that it is equal to angle N, and PQ, which is the included side, that is equal to the included side MN, which has been given also. So therefore, we can say therefore triangle PQR is congruent to triangle MNO. How? By the ASA rule of congruency. ASA rule of congruency. Or we can say by ASA congruence rule also. Or we can also say like this by ASA congruence rule. That also we can say. We can write this also. So I will say so. Yeah, so hence it is proved now. So suppose it also had been asked to show that in the second part that prove that the side length PR equals to MO. So then we will write in the proof also that first we have to prove these two triangles are congruent, and the second part is shown that PR is equal to MO. So therefore here I will say that since now these two triangles are congruent, so I will write this proof part 1, and so I will say PR is equal to MO by CP/CT. Then also I will write proof part 2. Okay. Then we have the angle side rule, or the AAS rule, AAS rule of congruency. So in the AAS rule, the side which is not included with the two angles which we take, that we have to consider here. So the rule states that if two angles and a non-included side of one triangle are equal to the corresponding two angles. This word corresponding is very important in all the rules of congruencies. So we should always take care of the corresponding. The word corresponding, as we can see, that it is very important in all the rules of congruencies. Here also it is there in SSS rule also, in SAS rule also, and in ASA rule also. As you can see, the word corresponding appears here also, and the word also appears in the AAS rule also, and it will also appear in the RHS rule also. So if two angles and a non-included side of one triangle are equal to the corresponding two angles, and the non-included side of another triangle, then the two triangles are congruent. So here, suppose we take one triangle DEF and suppose one KLM. Suppose one triangle DEF and triangle KLM, and here suppose we can show that suppose angle D equal to angle K and angle F is equal to angle M, and we don't take the included side DF and KM. We take, suppose EF is equal to LM. Suppose it is told in the question that EF is equal to LM and angle D is equal to angle K and angle F is equal to angle M. Then also we will say that, so here also we can see that the vertex D corresponds to the vertex K and F corresponds to M and E corresponds to L. So it means we will say that triangle DEF, I can say that will correspond to triangle KLM. See, we have used the same order of correspondence while writing the names of the two triangles on the left hand side and on the right hand side of the congruency symbol. So this I will say, then therefore since EF is not the included angle, so it is the non-included angle. Here also LM is the non-included side. EF is also the non-included side here. EF is the non-included side since we took the angles as angle D and angle F. And here also LM is the non-included side since we took angles K and angle M. So here I can say triangle DEF will be congruent to triangle KLM. How? By the AAS rule, by the angle side rule of congruency. So we can understand this rule by using one application. Suppose it is told that in triangle ABC, and triangle PQR, angle B equals to angle Q and angle C equal to angle R and AC equal to PR. Then show that the first part, show that triangle CBA is congruent to triangle RQP, and the second part is, and yeah, the second part is that BC is equal to QR. BC is equal to QR. That also you have to prove. So we have to show that triangle CBA is congruent to triangle RQP and the side BC is equal to QR. So then we will draw the triangles ABC. Is the triangle ABC and triangle PQR. So now it is told that angle B equals to angle Q and angle C that is equal to angle R. And AC is equal to PR, it is told. So now simply first we will write the given, what is given in the question. So the given part we will write this only in triangle ABC and triangle PQR, angle B equal to angle Q, angle C equal to angle R, and AC equal to PR. Then this show that part we will write in the to proof. So to prove is, we have to prove that first is triangle CBA is congruent to triangle RQP, and the second is BC equal to QR, that we have to prove. So here also, as you can see, the vertex A corresponds to the vertex B, and the vertex B corresponds to the vertex Q, and vertex C corresponds to the vertex R. So when we say triangle ABC, then we have to say triangle PQR. And when we say triangle CBA, then we have to say triangle RQP. And suppose we say triangle BAC, then we have to say that triangle BAC that will be congruent to triangle QPR, since we have to use the same order of correspondence. So in the proof we have to write The proof is, so I will tell in triangle ABC and triangle PQR, it is given that angle B equal to angle Q, which is given, I will write. So for every statement we write on the right hand side, we have to give the reason also. So either it is given or it can be proved earlier also, or it can be according to the construction also. So every reason we have to write in brackets on the side of every statement which we use. So for each and every statement, we have to give the proper reason also for each and every statement. So then, so angle B equals to angle Q and also angle C equal to angle R. The reason is same. The reason is it is given. And then AC, the side AC equal to side PR. Since why that is also given. So therefore, I will say triangle ABC correspond is congruent to triangle yeah, PQR, or, or since the correspondence, since A corresponds to P and B corresponds to Q and C corresponds to R. So we can write the name in the reverse order also on both the sides. So we can say, or triangle CBA, that also is congruent to triangle RQP. How? By the reason is by AAS rule. Since here the side which we took here, as you can see, the side AC is the non-included side. Is the non-included side. Since why we haven't taken BC, since why BC is the included side, and here also QR is the included side, the side which is included with the two angles which we have considered, then that will be called the included side. So here QR is the included side, and PQ and both PQ or PR, they are non-included sides. Non-included sides. Here also BC is the included side, since it is included with the two angles which we have considered here, angle B and angle C. So this is the included side, but AB or AC, they are non-included sides. So here we can say, therefore, triangle CBA is congruent to triangle RQP, or we can also say triangle ABC is congruent to triangle PQR by AAS rule of congruency. AAS rule of congruency. And therefore, we will say, so I can say side BC also will be equal to QR now by CP/CT. So hence we will write hence proved. Hence proved also we can write at the end, or here on the side we can write proved part 1, and here we can write proved part 2. Then after AS rule we have RHS rule. The last rule is the RHS rule of congruency. RHS rule of congruency. So this rule states that if the, so this rule is applicable only for right angled triangles. So this rule is only for right angled triangles or right triangles. Only for right triangles this rule is applicable. So the rule states that if the hypotenuse, as we know, the hypotenuse is the longest side in a right angle triangle, and the hypotenuse is always the side which is opposite to the right angle. The side which is opposite to the right angle, that is called the hypotenuse, and that is the longest side in a right angle triangle. Longest side in a right triangle, I can say. So the rule states that if the hypotenuse and one side of a right angled triangle, hypotenuse and one side of a right angled triangle are equal to are equal to the hypotenuse and the corresponding side. So if the so the hypotenuse we have to take and any other side we have to take. And one side of a right angle triangle are equal to the hypotenuse and the are equal the hypotenuse and the corresponding side in the corresponding side of another right angle triangle of another right angled triangle, then the two triangles are congruent. Then the two right triangles, then the two right angled triangles are congruent. So this rule is applicable for right angle triangles only. So then the two right angle triangles are congruent. And as we have said that two triangles are congruent, it means they can exactly overlap on each other. They can exactly overlap on each other, since why they will have the same shape also and the same size also. They will exactly overlap or they can exactly coincide one on each other. So here, so simply it means that suppose if we take two triangles, suppose PQR and LMN, we have to take two right angle triangles PQR and LMN. So here, as you can see, angle Q is equal to angle M since they are right angles. Both are 90 degrees, means angle Q is equal to angle M, which are equal to 90 degrees. And if we can show that PQ, the side PQ is equal to LM, since PQ here it is the hypotenuse of triangle PQR. And similarly here LN is the hypotenuse of the triangle LMN. So if we can say that if we can show that PR is equal to LN and any other side is also equal, suppose we can show that PQ is equal to LM also, PQ is equal to LM, then we can say that triangle PQR will be congruent to triangle LMN, since here you see P corresponds to L, Q corresponds to M, R corresponds to N. So we will say triangle PQR, the same order I will use here also, same order of correspondence. So triangle PQR will be congruent to triangle LMN by the RHS rule of congruency or RHS congruence rule. RHS congruence rule. And once we have shown that they are congruent, then we can also say that all the other angles and all the other sides are also equal by CPCT. Simply it means we can say that angle P also will be equal to angle L, angle R also will be equal to angle N, and also RQ also will be equal to NM by CPCT. So we can understand this rule, the RHS rule, by using one application. So suppose it is being told that in triangle ABC and triangle PQR, it is given that angle B, yeah, or say, let's say it is not PQR, it is suppose. So suppose it is told in triangle ABC and triangle DEF, angle B equals to angle E, which is given as 90 degrees. And it is also told AC is equal to DF, AC is equal to DF, and AB is equal to DE. AB is equal to DE. Then we have to prove that, the first part is that triangle BCA is congruent to triangle EFD. BCA is congruent to triangle EFD. And second part is told that we have to show that angle F, or yeah, angle F is equal to angle C. Angle F is equal to angle C, or simply it is told to prove that angle EFD, that is equal to angle BCA. So this we have to prove. So how to prove? First, we will draw two right angle triangles, since the RHS rule is applicable only for right angle triangles. So here we'll say ABC. Since we have to put B here only, since it is told angle B is the right angle. So B is 90-degree here. And also we will draw triangle DEF. This is DEF. DEF. So angle E is right angle. So we have to put the vertex E here only. So here angle P is the right angle and here angle E is the right angle. So obviously here we can see that it is told AC is equal to DF. So AC is the hypotenuse and DF is the hypotenuse here. So in the two triangles we can see that the vertex A corresponds to D and B corresponds to E and C corresponds to F, obviously. So AC is the side which is opposite to the right angle. So AC is obviously the hypotenuse here. And DF is the side which is opposite to angle E. So DF is also the hypotenuse here. So I can say that, so it is given that AC is equal to DF also, and AB is equal to DE also. So first we will write the what is given. Given is that in triangle ABC and triangle DEF, angle B equals to angle E, which is equal to 90 degrees. And then AC is equal to DF and AB is equal to D. AB is equal to D. This is given. Then to prove, we have to prove that the first part is triangle BCA, that is congruent to triangle EFD. So here also we can see the order of correspondence is kept same while writing the names of the two triangles. Here, as you can see, B corresponds to E and C corresponds to F and A corresponds to D. So if we say ABC triangle, then we have to say it is congruent to triangle DEF. And when we say triangle, suppose BCA, then we have to say it is congruent to triangle EFD. And suppose we say triangle CAB, then we have to say it is congruent to triangle FDE. Since we have to take the same order of correspondence while writing the names of the two triangles on the left hand side and the right hand side of the congruency symbol. So here in the second part, it is asked to prove that angle EFD, that is equal to angle BCA. Okay. So how to prove? The proof is that I will tell that in triangle ABC and triangle DEF, say angle B equals to angle E, which is the right angle, 90 degree, which is given, and AC is equal to DF, it is also given. I can say which is the hypotenuse. Hypotenuse AC is equal to hypotenuse DF, and also the side AB is equal to DE. The side AB is told that is equal to DE, which is also given. So which is another side except the hypotenuse. So therefore, I will say therefore triangle ABC is congruent to triangle DEF, or simply I can say or I can write it here, or triangle BCA, that will be congruent to triangle EFD. Since why we have to maintain the same order of correspondence. So the reason is by RHS rule of congruency. So these two triangles are congruent by RHS rule of congruency. Since why one triangle is a right angle, one triangle in both the triangles is right angle, and the hypotenuses are equal, and another side is also equal to the corresponding side of DF. So the side AB of triangle ABC is also equal to the corresponding side, which is DE in triangle DF. So therefore, these two triangles are congruent by RHS rule of congruency. So this is the proof part 1, and so we can also say that the angle EFD means this angle, that will be equal to angle BCA, which means this angle, since they are the corresponding angles in the two congruent triangles. So they are equal. So therefore I will say angle BCA, that will be also equal to angle EFD. BCA is equal to EFD. So, and then I will write hence. So hope all of you have understood all these rules of congruencies of triangles. Still any doubts if you have, please write that in the comments. We shall obviously clarify them. So thank you everyone.